Welcome all. Welcome to second week of the second session, discussion session of the course Strength of Materials course offered by NPTEL. And the course instructor of this course is Professor Shriman Kumar Bhattacharya. He is a professor from IIT Kharagpur. Myself, I am Asif Raza. I am a teaching assistant. I am a PhD scholar from Department of Civil Engineering, IIC Bangalore. Last time I told you all that. In the discussion session, normally what we'll be doing is one of the halves will involve the discussion of assignment of the current week, and the other half would include the discussion of the actual assignment problem. So since assignment 1 uh, problem is still due date is not over, so we won't be discussing it today. So we'll be discussing questions relevant to assignment number 2 only, and some questions relevant to assignment 1 as well. So we'll work it out, and students are encouraged to ask your doubts if you have any pertaining to the lectures, and if you are not able to ask it here, you can ask in the discussion forum also. So try to utilize the forum as much as possible. Okay, so we'll start today's discussion session. So I'll directly asking questions of the second week. So first question, and you guys can give your answer in the chat box, what you feel is correct. So the question is, select the wrong options from the following statement. First option is first statement is shear stresses in principal plane is non-zero. Second statement is normal stresses in principal plane is always compressive. Third statement is shear is 0 in principal plane, and the fourth option is none of the above. So you guys can give your answer pertaining to this. What do you think? What would be the answer? I'll magnify this a bit. I hope the questions are visible. So you guys can give the answer in the chat box also. Take your time. So Paras has given an answer as option C. What about others? Okay, you're saying C is right. The question asks selecting the wrong options. So choose your answer carefully then. Others? No one? Okay, I myself will give the answer then. I would try to ask you all to give your answers, whatever you feel, whether be it wrong or not. Okay, so Pashupuleti has given answer as option A. Okay, no one else. I hope today's prerequisite is the second week's lectures. So I hope you guys have already gone through all the lectures of the second week. Then only you'll be able to understand the questions. So we can see that all the questions pertaining to the options are related to principal plane, and the definition involves the principal plane is that plane where shear stress is 0. So as Paras has already said, this is a correct statement. Okay, and we need to choose the select wrong options from the following statements. So shear stress is zero in principal plane. This is a correct statement. So this implies this first option is a wrong option, right? It's a wrong statement. And let's see about the second option. So second option says normal stresses in principal plane is always compressive. So this is not a true statement. That can be tensile also. So this is also a wrong statement. So correct option would be option A and option B. So this is kind of a multiple choice, A and B both. Okay. Moving on to the next question. Hope that is okay for all. Okay. Second question is the angle between the principal plane and the plane with maximum shear stress in a physical element is. So options are 45 degree, 30 degree, 0 degree, 90 degree. Suppose we have the element, okay, with stress sigma x tau xy tau xy. Right. So suppose my principal stress lies here in this plane. So if I draw this side would be sigma 1, perpendicular it will come out to be sigma 2. Where would be the plane with maximum shear stress? Okay, no answers. Uh, can I ask you all, like, do you know Mohr circle or not? Anyone can let me know whether you guys know Mohr circle or not. Anyone? Hmm, no response. Don't know. Like that's pertaining to the second week's lecture. Okay, let's try to solve it. Okay, I'll provide the lecture pertaining to this, then you guys might be knowing. Okay, let's do this. First thing first, uh, you guys know this, right? Sigma xx, sigma xy, or you know this one, sigma x, tau xy, 0, tau xy, tau sigma y. If I talk about in the 2D, don't have clarity. Okay, no problem. Okay, so normally at any point we can draw a stress diagram like this: sigma x, sigma y, sigma y, tau xy, tau xy, tau xy, and tau xy. Right? At any plane theta, we can have a normal sigma and tau pertaining to it, right? Now let's, if you want to find what would be my sigma and tau, I feel like saying Okay, no problem. Let's discuss it. So, if you have come across with the lectures, this would be like sigma x plus sigma y by 2 plus minus sigma x minus sigma y by 2 whole square plus tau xy square, and this would be equal to this sigma x minus sigma y by 2 whole square plus tau xy whole square. This is like uh, at any point this sigma x sigma xy tau xy can be drawn, right? So from this, like if I take an any angle theta, we can find any sigma and tau. These are pertaining to, sorry, these are pertaining to the principal stresses. So sigma in this would be what? If I resolve it, sigma x cos theta, kind of like that. What I mean to say is, suppose if you want, if you draw in the Mohs circle is, what do we get? Is we have sigma axis in the as a x axis and tau as a y axis. Okay, so let us take the sign convention like this. Sigma x, if I take it being positive, like positive in the x only, so this would give me as I take positive in this direction for x-axis, and for sigma y I take uh, on the positive face being in the positive direction, and tau xy as in down in the x face, positive x face. Suppose I take this. Now uh, uh, for any stress of this point can be like we can draw the Mohr circle, or uh, uh, so this body is represented by these points, right? Sigma x2 xy, sigma y tau xy. These are 2 points. Like if I find the stress here, this would be sigma x tau xy here, and here sigma y tau xy is the point. So suppose sigma x tau xy is here, suppose, and sigma y tau xy is, if it is positive as well, let us take it a bit lesser than sigma x. So this is sigma x tau xy, and let's take sigma y uh, tau xy here. Okay, so using these 2 points we can draw a circle such that, so we have, this is sigma y. Okay, and now this will have a certain center. So what is the principal stress? Principal stress is uh, principal stress is or principal plane is the plane at which shear stress is 0. Okay, so if I see in this Mohr circle, there are 2 points where my shear stress is 0, at one point here and at other point here. So these are the two planes where my shear stress is 0, and this would give me as in sigma 1 and sigma 2. This would be the principal stresses in this. So these things I am talking about, these are roughly. And so from sigma x, so I drew sigma x, right? This was my sigma x, and from here theta. So if I go theta, and if I go theta, if I'm going theta from here, in the Mohr circle will be going 2 theta. It's kind of 2 theta. Okay. So now we'll be getting some stress points, right? This and this. Okay. This will be the stresses, like stresses in the new plane, this resolved plane on which we are trying to find. So this will be the sigma and tau pertaining to this. Okay. And principal stresses are given by this relation directly: sigma x minus sigma y by 2 whole square tau xy whole square, and tau in the principal plane is sigma x minus sigma y by 2 whole square plus tau xy square. Okay. So in the question in which I asked is the angle between the principal plane and the plane with maximum shear stress in a physical element is. So normally, suppose I take the case sigma, sigma, sigma. Okay, there are no other stresses I am taking. Okay, suppose. So what would be my Mohr circle pertaining to this question? So sigma axis is in the x, sigma is x axis, tau is y axis. So suppose sigma is equal to 50. Okay, 50 would be around here. Okay, now sigma x is equal to 50, sigma y is equal to 0, and tau xy is equal to 0. Okay, so this would give me coordinates would be what I told you, it is kind of sigma x tau xy, sigma y tau xy. So this would be 50 comma 0 and 0 comma 0. So one point would be kind of this 50 comma 0 say, and this is 0 comma 0. So our Mohr circle would be kind of joining these 2 points. Okay, and center would be around here, that would be around 25 comma 0. Now see in this curve itself, circle itself, what is my so principal plane is what? Principal plane is where my shear stress is 0. Okay, so those points are here and here. Okay, and what is, and another question is plane with maximum shear stress. Okay, so in this circle, what is the maximum shear stress? Where is it? So it is either this or either this. So this point or this point. Okay, and what is the angle between this? From here to here, this theta is equal to 90 degree. Okay, so the plane with maximum uh, principal plane and the plane with maximum shear stress in the Mohr circle, it's equal to 90 degree. Okay, and as I told you, in the physical element, if we move an angle theta in the Mohr circle, we actually move an angle 2 theta. So if in the Mohr circle it's an angle uh, like, so in reality it's 2 theta is equal to 90 degree. So in the physical element we are moving actually 45 degree. Okay, so that is what the question is asking. What would be the angle between the principal plane and the plane with maximum shear stress in a physical element? So as so in this So in this question itself, I took the example, if this is having sigma and 0, so this itself is one of the principal plane. Okay, because shear is 0, shear stress is 0, right? Now if I at what angle of this section, okay, at what angle of this section should I move so that I'll get my principal stress? So I'm saying it would be equal to 45 degrees. So that is what. So it would be kind of, if I resolve it at 45 degree and I draw a, like, at 45 degree, if I draw the stress contour, okay, uh, draw the stress diagram. So kind of see here 90 degree. Okay, at 90 degree we have uh, stresses as, if you see, it's 25 comma tau, and see, if I took this as 50, this would be 25, this would be 25, and since it's a circle, so this would be also 25. So tau would be also, tau max would be 25. Okay, so in the result where my principal stresses is maximum, the coordinates are this 25 comma tau max and minus 25 comma tau max. Okay, kind of, if I draw it in the physical element, so it's plus 25. So plus 25 would be like this, 25 tau max. Okay, oh, sigma minus tau max. So this is tau max as in this one 25, this would be 25, this would be 25, here it would be 25, and okay, I'll use a different color. This is 25 for sigma x and this color for sigma y, 25 and 25. Okay, so this is what, like, in the physical element, this is having, this is with respect to the principal plane and this is with respect to the maximum shear stress. So the angle between the principal plane and the plane with maximum shear stress in a physical element, the correct option would be 45 degree. So again, if I ask you all, if I rephrase the question, as just now I told you, if I rephrase this question, and let me write it as, okay, I'll write it down here in itself. Question, modified question. Okay, so if what would be the question answer if the question asked is the angle between the principal plane and the plane with maximum shear stress in a physical element is, and options are the same: 45 degree, 30 degree, C 0 degree, D 90 degree. So what do you think? What do you all think? What would be the answer? Oh, sorry. Question is I wrote is exactly the same. Not the physical element in the Moha circle. In the Moha circle. What would be the answer? Yes. Yeah. Rakesh, you can unmute and say. Nirpati Rakesh, you raised hand. You can. Okay. Give the answer. Yes, it's 90 degree only. If you have doubt, you can ask that too. If you feel like it. Yeah, it's nice. Everybody has got something. Okay, we'll move on to the next question. I'll just load this. So I just gave this answer. Let's see if you guys got this or not. So the question is, a rotation of angle 2 theta in Mohr circle actually represents rotation of theta by 2 in a physical system, rotation of theta in a physical system, rotation of 2 theta in a physical system, or rotation of 4 theta in a physical system. Uh, yeah, Rakesh, have you raised hand for this question or the earlier one? Okay, Paras has given answer. Rakesh, if you want to give answer pertaining to this, you can give. So Paras has given answer as option B. What about others? As recently I just told you, and the question which I modified also was pertaining to that only. Come on, guys, be quick enough so that we'll move on with other questions also. Hmm. I just gave the answer pertaining to this. Okay, Akhil has given answer as option A. No problem. Rakesh has also given answer as option A. Okay. Okay. So I'll just explain it. So the question asked is, if in the rotation of angle 2 theta in Mohr circle. So question asks, if we move an angle of 2 theta in Mohr circle in the physical system, what angle we are actually moving? In the question, as I explained earlier, if we are moving by an angle 2 theta in the Mohr circle in the physical system, we actually move by angle theta, right? So 2 theta, if you are moving the Mohr circle, we should actually move by an angle theta. So this would be the correct answer. This would be correct answer if we move by an angle theta in Mohr circle, then theta by 2 would be in the physical system. Okay, I hope Akhil and Rakesh as understood their mistakes. Okay. Uh, Moving on to the next question. If nobody asks anything, let's add it. Question 4. Okay, this is a bit interesting one. Okay. So the question is, what would be the Mohr circle for hydrostatic stress state? And options are provided. I hope it's visible for you all. So first thing first, I would ask you all, what is hydrostatic stress state? What is the hydrostatic stress state? Can any one of you unmute and tell me about it? Anyone? Come on, guys. Come on. Okay, if you guys, uh, should I wait for anyone or should I tell? Hmm, component of stresses which contains uniaxial stresses. Uh, um, but not shear stresses. Can you elaborate more? Like if I draw the element, okay, so I just draw the usual thing first. Then you tell me what to omit, what not to omit. Okay, it's best I draw with a different color here. Okay, you can unmute yourself and tell me what not to keep, what to keep, and how much to keep. Possibility, if I may. Come on, don't worry. You might be wrong. We are having a discussion session only. You won't be graded on this. Come on. Anyone? Or if you are feeling shy about it, you can write it in the chat box. I've written the like sigma x with the red, sigma y with the green, and shear stress with the yellow or orange. Okay, Rakesh has just given the answer as option C. Uh, Rather going to the answer directly, let's work it out. What is an hydrostatic stress state? I think you guys don't know what. Okay, I I think Pashupalati has some certain gist about it, but I don't know. Component of stresses which contains uniaxial stresses but not shear stresses. So you're right in one sense that there won't be any shear stresses. So I'll just remove these shear stresses. Okay. Now you're saying component of stresses which contains uniaxial stresses. So should I say sigma x and sigma y both would exist or not exist? Both should exist, right? But there is some certain string attached to it that both should be equal. So if I say sigma x and this as sigma y, for hydrostatic stress state, sigma x is equal to sigma y. This is what we have, okay, and tau xy is equal to 0. This is what we mean by hydrostatic stress state. And if we draw more circle pertaining to this, so let's try to draw it. This is the sigma axis, this is the tau axis. So we have the coordinate sigma x comma tau xy, sigma y comma tau xy. Okay, so sigma x, suppose any value, it would be sigma x comma 0. Suppose say this. Okay, now the other point sigma y comma 0 would be where? It would be exactly here itself, right? Sigma x comma 0 would be also here, and sigma y comma 0 would also be here, because sigma x is equal to sigma y. And since both points coincide, we won't be able to draw a circle. In this case, the circle itself is it's exactly a point. So the correct answer pertaining to this would be option B. Okay. Now let's see. Rakesh gave answer as option C. So let's see what kind of stress state is option C is. So in option C, if we can see uh, maximum or principal stress states are like, if it is sigma 1 here, this would be suppose sigma 2. Sigma 2 is exactly equal to minus of sigma 1. Okay, like my negative of this, and here tau max is equal to sigma 1. If you can see, the magnitudes are same. Okay, so it's actually the case for pure shear. Okay, this is the case for pure shear. This is the case for hydrostatic stress state. Okay, let's see option D. So if you see the option D, actually I draw this in the second question itself. This question, like I try to give an example. So if you see the question, the most stress corresponds to the question where I just applied sigma only in the x direction. Okay, so kind of we get sigma 1 here, and this is 0, sigma 2 is equal to 0, and this is tau max, which is equal to sigma 1 by 2. Okay, now this case pertains to what? Uniaxial tension. So these are kind of standard examples, so you guys can remember it if you want. And this is a general case, okay, where there is some like both sigma 1 and sigma 2 are greater than 0. Okay, that's it. Let's move on to the next question. I hope nobody has thought pertaining to this question. Let's move on. Question 5. The question is, the pure shear stress and maximum shear stress in a physical system coincides when? And the options are: principal stresses are both compressive, principal stresses are both tensile, principal stresses are equal and opposite in direction, and principal stresses are unequal and opposite direction. So you guys can relate this thing uh, with the example I just said. So see, this is the case of pure shear, right? Pure shear. I gave the example. You guys like see this uh, Mohr circle diagram. I've given the answer. Let's see how many of you guys can say and choose the option from here. Okay. So I draw the case for pure shear. Let's draw it again. Okay, let's draw this. It was kind of this, not a good artist. This is sigma axis, tau axis. This is pertaining sigma 1, sigma 2, tau max minus tau max. So Paras has given answer as option C. What about others? Others? Okay, Vignesh has also given answer as option C. You guys can like ask question if you're not getting the question itself, or if you're feeling any comfortable about it, you can unmute yourself and like you can raise hand, and then I'll ask you to unmute and let me know if you feel you're up to it. Let me know. Okay, so out of 11 people, only 2 of them has given answer as option C. Others, come on. At least just type in the chat box so that I may feel comfortable, that I will feel assured that you guys are you have understood this question, you got the answer. Okay, I'll just give the answer now, since you guys are not being responsive about it. So as Vignesh and Paras said, answer is option C. Yes, because as just now I told about this pure shear case. Here sigma 1, this is the uh, principal stress, and sigma 2 both are equal and opposite. See this one, okay, and tau max is equal to the magnitude of them all. So pure shear stress and maximum shear stress in a physical system coincides when the principal stresses, this one, are equal and opposite. Okay. Let's do the next question. Question number 6 it is, right? Yeah. Six. So this is also been discussed Let's see how many of you can get it. The question is, for a body under hydrostatic stress, what is the magnitude of the maximum shear stress? Okay, uh, I'll just give you guys hint. This was the case for the Mohr circle for hydrostatic stress, and the correct option was option B. Now the question says, what is the magnitude of the maximum shear stress for the case of hydrostatic stress state? I'll draw the Mohr circle again for you all if you guys got it. Sigma top, and it was like this. Okay, one of them, titled Naruto no Uzumaki, has given answer as option A. Others, A. Rakesh has given answer as option B. It's good. You just gave answer. No problem being wrong. Paras has been the consistent one to answer. What about Pashupuleti? What do you feel? What would be the answer? Are you guys there? C. Okay, that's a different thing. I got it. This by Pashupuleti. This from Rakesh, and this from Paras. So we and so we are kind of 2-1-1. Any others? Option B by Akhil. Okay. Vignesh also is saying option B. Now 2-3-1. Okay, I'll highlight some of the thing. Okay, and let's see if you guys change your answers or what. So this is the Mohr circle pertaining to the hydrostatic stress case, right? And the question asked is, what is the magnitude of the maximum shear stress? So what do you think? What is the maximum shear stress in this Mohr circle? Tarun gave answer as option C. I would give you guys time to change your answers if you may. I gave you the hint like this is the Mohr circle for the given case, and the question asked is, what is the maximum shear stress? What is the maximum shear stress, right? Question says simple thing. And yeah, Prasanna is saying option A. Okay, so now we are kind of 3-3-2. Oh, Prasanna has changed his answer from, okay, 3-3-1. Anyone else want to change the answer? It's okay. See, this is uh, uh, sigma axis. This is the shear stress axis, right? And if I draw the Mohr circle and we are getting a point, so for throughout the domain, what is the value? It's coming only like if it is sigma h, so its value is sigma h comma 0, right? It's just a point on the sigma axis, so sigma h comma 0. So the domain itself has only value called 0 in the shear stress. So maximum value or the minimum value, whatever you say, the value is equal to 0 only, right? So correct answer would be option A. I hope it's clear for everyone. See, this is the stress axis, right? X and y axis, there is only a point on the x axis, and x axis pertains to normal stress, while the y axis pertains to shear stress. And since it lies on the normal stress, shear stress would be equal to 0, so the maximum shear stress itself is 0. Sigma h by 2, some of them gave answer as option B, sigma h by 2. That is the case for uniaxial tension, I think. Yes. This is for the uniaxial tension. Okay. Moving on to the next question. If nobody has doubt, if you feel like I'm not making any sense, you guys can ask. Okay. Moving on. Question 7. So this would require a bit of calculation. Just a bit more. Say the question is, we are given with the state of stress of at a point sigma x is equal to minus 30, sigma y is equal to plus 30 MPa, and tau xy as 15 MPa. The magnitude of maximum and minimum principal stresses is. So I'll give you guys time to calculate. Meanwhile, I'll just write the formula for you all if you don't remember it. I wrote it in the starting of the session. Still, I'll just write it. Sigma 1 comma 2 is sigma x plus by 2 plus minus sigma x minus sigma y by 2 whole square to x whole square. Okay. Just let me know, okay, if you guys can solve it as fast as possible. Anyone? this case sigma x is minus 30 MPa, sigma y is plus 30 MPa, and tau xy is plus 30 MPa. Okay, sorry, 15. The sigma 1, I'll take the plus sign here, sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 whole square plus tau xy square. So this would be equal to minus 30 plus 30 by 2 plus minus 30 minus again 30 by 2 square. Tau xy is equal to 15. So this is equal to this. Okay, so this would be equal to 0, and this would be equal to 30, 60 by 2, 30 square plus 15 square, right? So this would be kind of 15 root 5, and Paras has given answer as option D. Let me see, root 5. So sigma 1 comes out to be 33.54 megapascal. Sigma 2 would be equal to what? Sigma x plus sigma y by 2 minus sigma x minus sigma y by 2 whole square plus tau xy whole square. And since this part it is 0, right? So, and we have calculated this part, and it comes out to be minus 33.54 MPa. Okay, yes. So Paras is correct answer. Correct answer would be option D. So if I may ask, what would be maximum shear stress for this case? And options are the same, A, B, C, D. Let me know. Like options are the same. Leave this one. Okay, just write it plus 39 MPa. I'll write something 15 MPa. This one has 25 MPa, and this one is same 33.54 MPa. What would be the answer? The magnitude of maximum shear stress for the given example. Yeah, Vignesh has given answer as option D. Others? D. Yeah, that's nice to see. Yes, the correct answer would be option D only. Because, uh, tau max is equal to what? Plus minus sigma x minus sigma y by 2 whole square plus tau xy whole square. And this we already have calculated, 15 root 5, that gives me 33.54 MPa. Okay, let's modify the question a bit, and let's see you guys give the answers as soon as possible. The question is, it's the same thing, I'll just change the values. Okay, so the state of stress at a point is given by, so sigma x is equal to minus 40 MPa, sigma y is equal to 40 MPa, and tau xy is equal to 30 MPa. The magnitude of maximum shear stress is, and the options are 10 MPa, 30 MPa, 50 MPa, option D as 100 MPa. Let me know. It's quite, just it needs a substitution and work it out. Okay, Rakesh has already come up with his answer. So Rakesh is giving answer as option C. Others? Come on guys, it's just an easy substitution question. What formula required would be this: tau max is equal to plus minus sigma x minus sigma y by 2 whole square. Okay, so possibility is also given as an answer as option C. And so tau max is equal to plus minus sigma x minus sigma y by 2 whole square plus tau xy whole square. So sigma x is minus 40, sigma y is plus 40, so this would give me this, and tau xy is 30, so this plus minus 40 square plus 30 square, and this would be 1600, 900, 2500, and this would be 50 megapascal. Okay, nice. So answer is option C. Okay, I'll just now I won't give the options, rather I will ask you all to give the values. What would be sigma 1 and sigma 2? Answer. Because one part of the answer is 50 itself, you just need to take the average and just add and subtract. Anyone? You just type in the chat box itself. Anyone? Come on, guys. just give you the hint. See, when sigma x and sigma y is of opposite sign and they are equal, so question was what? The maximum shear stress is kind of equal to the value of the stress itself. Pure shear stress is equal and maximum shear stress in a physical system coincides. Lot of questions are there similar to it. Weakness is saying 2500 MPa. I think you forgot to take the root, square root. No problem. So sigma 1 comma 2 is what? Sigma x plus minus sigma x plus sigma y by 2 plus minus tau max. Okay, I'll just write it as tau max here. And sigma x and sigma y is both equal to 0. Okay, so both not equal to 0 but opposite sign and equal. This would be kind of 50. This is 0, so answer would be 50 megapascal. Achilles said 50 comma 0. I differ. It would be plus minus 50 megapascal. Means sigma 1 would be equal to 50 megapascal and sigma 2 would be equal to minus 50 megapascal. Not sigma 2 won't be equal to 0 because uh, the formula requires this. Sigma 1 comma 2 is sigma x plus sigma y by 2 plus minus sigma x minus sigma y by 2 whole square plus tau xy whole square. Okay, means like if you're confused, let's see, sigma 1 is equal to, you take the plus 1 here. Okay, sigma x minus sigma y by 2 whole square plus tau xy square, and sigma 2 is equal to sigma x plus sigma y by 2 minus of sigma x minus sigma y by 2 whole square plus tau xy. Okay, I think you got the mistake. Okay, let's move on to the next question. So lastly we discussed question 7. Let's discuss question number 8. So this also requires the calculation of principal stresses. Okay, but using the mass stress, the stress plots from the physical element itself, and given in the x it's 75 megapascal, in the y direction it's 50 megapascal, and shear stress as 10 megapascal. Options are 50.8 and 31.1. Option B as 50.8 and 75.8. Option C as 75.8 and 19.5. And option D as 75.8 and 23.1. So this would require serious like better see the sign of the stresses properly, and let me know what do you guys get the answer. So So first thing to do in this case is you need to point out what is the sigma x value, sigma y value, tau xy value, and then you guys need to use the formula, right? We'll just again write the formula. So sigma 1 comma 2 is equal to sigma x plus sigma y by 2 plus minus sigma x minus sigma y by 2 whole square plus tau xy whole square. Okay. Okay, let's go step by step, brother. I should involve you all to speak on this. So what is sigma x? Anyone? What is sigma x? It's quick. Let's be quick on this. What is sigma x? Guys can directly unmute yourself and speak or type in the chat box. It's 75 megapascal, but is it okay? Most of them, I think you are getting it wrong here. So if you see it properly, see the direction. It's not this, it's actually inside. So that would imply it would be minus 75, not plus 75. Okay, sigma x is minus 75 megapascal, sigma y is this, right? So it would be plus 50 or minus 50. Yes, so it would be plus 50. Yeah, nice. And tau xy would be equal to, so earlier I drew the sign convention, kind of sign convention. Yes, Rakesh has said answer is plus 10. Kind of I drew this, okay? Yeah. So with this, tau xy would be equal to 10. Sign of tau actually doesn't matter much. If you see in the calculation, it always comes with a square, okay? So sigma x and sigma y, this matters more importantly, okay? The sign of normal stresses matters much, okay? Now let's substitute it in the formula and try to find it. So sigma x is equal to minus 75, sigma y is equal to 50 by 2 plus minus sigma x is minus 75, sigma y is minus 50 by 2 whole square plus tau xy is 10 whole square. This is equal to what? Minus 25 by 2 plus minus. This would be equal to minus 125 by 2 whole square plus uh, 10 square. So this would be equal to minus 12.5 plus minus, okay, so 12.5 sorry, 125, it's equal to 62.5 and square. So this is equal to 3906.25 plus 100. Okay, go to minus 12.5 plus minus, so we need to take root of 106.25. Okay, so 406.25. This is equal to minus 12.5 plus minus this is 63.29. Okay, now just calculate it. Sigma 1 would be equal to, I take the plus 1, so this would be 12.5. It is coming out to be 50.79 or 50.8 megapascal, and sigma 2 would be, take the minus 1, this, okay, should not omit any step if you guys may get confused. So just write it here, minus 12.5 plus 63.29 equal to this. This is minus 12.5 minus 63.29, and this is equal to minus 75.79. So kind of minus 75.8 megapascal. Okay, 50.8 and 75.8. So question asks, say absolute value of principal stresses, maximum and minimum. So maximum is 50.8 and minimum is, like, if I take the absolute value, it's 75.8. Yeah, okay, it's nice to see. Rakesh gave an answer as in opposite, 75.79 and minus 50.59. Minus 50.79, that is wrong. Better to check your calculations. But in the context of like absolute value, yeah. So mistake minus, yeah. So answer would be 50.8 and 75.8. So it's best to do it properly. It's quite an easy question. You just need you need to see the sign convention and just apply it in the formula. Okay. Okay. I hope nobody has doubt now pertaining to the current question now. It was quite an easy thing. Let's move on to the next question. So question 9. Question 9. Okay. Question is, the number of stress component for a system subjected to plane stress condition is, options are 2, 6, 5, 3. You guys can write your options in the chat box. Question is, number of stress component for a system subjected to plane stress condition is. Let me know what is the correct answer, but from you. Okay, so weakness is saying as option D. Others? Okay. Akhil is also saying as option D. Naruto Uzumaki. Answer as 2. Okay. Anyone else? Number of stress component for system subjected to plane stress condition. Akhil, okay, Prasanna is giving answer. Akhil, you changed your answer as 2 or option number 2? Okay, just move on to this. I changed answer as 2. Okay. If it's comfortable with you, can I ask you to unmute yourself, and why do you think answer should be option 2? Like option A, answer would be 2. Any one of you, like whoever feels like, whoever feels answer is option A. Anyone? Akhil, if I may like ask you, yeah, unmute yourself. Yes.
Because it is in a plain condition. Plain condition.
Okay. So, what will be the stresses? Like if I, this is the plane
Like a
stress.
compression stress and tensional stress. See, compression stress and shear stress.
You're saying compression and shear. These are kind of types of stresses. So even I take this kind of, then there should be a tensile one or tension. If that also would take me to number of cases to be 3. Okay, I'll make your I'll try to help you. So there are two kind of stresses, right? Normal stresses and shear stresses. Mm, in 3D, in three-dimensional body, normally normal stresses would be what? Sigma x, sigma y, sigma z, and shear stresses are tau xy, tau yx, tau xz, tau zx, tau yz, tau zy. There are like 3, 6, 9, and uh, uh, normally these stresses are equal. So effectively 1, 2, 3, 3 normal stresses and 3 shear stresses. These are in the case of 3D. Okay. In the question asked is plane stress condition as in 2D. Right. In that aspect you guys would agree. So let's see what will happen. So normal stresses, I'll first write all the stresses pertaining to 3D: sigma x, sigma y, sigma z. Shear stresses tau xy, that is equal to tau yx, tau xz equal to tau zx, and tau yz equal to tau zy. Okay. But in 2D, z-axis doesn't play role. Okay. So in the normal stresses, I would remove sigma z. So all the z components we need to remove. Okay. So in the shear stresses, we'll remove this tau yz zy, then tau xz zx. So we are left with how many? 2 in the normal stresses, 1 in the shear stress. So total it would be 3 stresses. So number of stress component for a system subjected to plane stress condition is, answer would be 3. I hope I make it clear. Uh, did you guys get it? Like, I don't know what were you thinking. Either you might be thinking like there are only two types of stresses, normal or shear. Or maybe you guys would have been thinking only sigma x and sigma y. You guys must have counted, you must have left it out, this tau xy. Nevertheless, you see there are two normal stresses, sigma x, sigma y, and shear stresses tau xy, tau yx. So 2D in xy plane, I mean to say. Okay, if it had been like in the yz plane, so we would remove the components of the x1. Okay, 3D as in x, y, z. Is that clear for everyone? Akhil, is it clear for you?
Yes, sir.
Yeah, thanks. Thanks for confirmation. Moving on to the next question. If you, any one of you feel there's doubt, you can ask on the question. Okay, question number 10. Right? Yeah. Okay. Okay. So this is kind of new question for today's session that we have not discussed so far. So question is, for the state of plane stress represented by the stress element shown in question number 8, determine the shear stress and the angle at which it acts. Okay, so uh, half of the answer is, I think it's already covered. So we just need to find whether it's the angle at which it acts. So let's see first what is the question number 8. Question number 8 is this one. Okay, so I'll draw it again. Question number 8. So 75x here, then 15x in the vertical direction, and I think 10. Yeah. Okay. All right. Yes. So this is the stress diagram. Uh, Stresses acting on the body. So what would be the maximum shear stress? Let's work it out step by step. So for this, what was sigma x? Sigma x was equal to minus 75 MPa. Sigma y is equal to 50 MPa, and tau xy is equal to 10 MPa. Okay. So tau max is equal to what? Plus minus sigma x minus sigma y by 2 whole square plus tau xy whole square. Okay, and substitution, sigma x is minus 75 minus 50 by 2 whole square plus tau xy is 10 whole square. This is 75. Okay, 125, that is 62.5 whole square plus 100. This was kind of 400, 4000 something, right? We calculated it. Yeah, so it came out to be this 63.29. Okay, 63.29 MPa. Okay, so one of the thing is done. What is the maximum shear stress? But we need to see the angle at which it acts. Okay, So for that we need to use this tan 2 theta p is equal to minus of sigma x minus sigma y uh, by 2 upon tau xy. Okay, do it and let me know. So with one part of the answer, it's like 63.29. So you guys must be thinking A should be the answer, but there is an option none of the above also. So we need to make it clear the angle is 40.545, then only it's correct. Okay, and this theta equal to 40.45, it's in degree to make it clear for you all. It's in degree, okay, not in radian. So did you guys get the answer? Still working out? Let me know. So this is equal to minus sigma x minus sigma y by 2 tau xy. This is equal to minus of sigma x is minus 75, sigma y is 50 by 2 tau xy was 10, right? So this gives me minus minus will convert into plus. This is equal to 125 by 20 into 10. This is equal to, okay, 20 to 10, that is correct. So this is equal to 6.25, right? 62.5, 6.25 tan 2 theta p. So that is 2 theta p is equal to tan inverse 6.25. To find this, let's see. So this comes out to be 2 theta p is equal to 80.909, or add uh, 180 degree to this, so that would be equal to 260.909. So that gives me theta p is equal to, I'll just divide it, 40.4545, or uh, this is 130.4545, okay, degree. So both of the options would be correct. Minus 44.95. Rakesh is giving me answer as 40 minus 44.95. I think you got to check it. it should be this only, 40.45 and 130.4545. Kind of mm, yeah. So with that, the correct answer would be option A for sure. Okay. So if there had been an option, like suppose if there had been an option like this, 63.294 MPa with theta equal to 40.4545 degree. Okay. Option A. Option B as 63.294 MPa with theta as 130.4545 degree. C as 23.57 41.22 MPa with theta as 130.4545 and D as 23.57 MPa with theta equal to 51.22 degree. What would have been the answer? Which one would you have selected? Anyone? We just found the result. You guys can give the answer. Yeah, both A and B would. So that would be kind of multiple choice answer. Okay, so you guys need to see the options and answers correctly. Okay, let's move on to the next question. Question number 11. Is it? Yeah. So this is quite a straightforward question. The radius of Mohr circle is equal to which of the following? Options are tau max, twice of 2 tau max, C is sigma 1 minus sigma 2 by 2, and D is none of the following. Radius of Mohr circle is equal to which of the following? So I'll just show you the standard cases like we discussed this. Where is it? Yeah. These were the standard cases. So radius of the Mohr circle would be equal to what? Just move on to that question. Yes. So radius of Mohr circle is equal to which of the following? Vignesh has given answer as option C. Nikhil has given answer as option C. Yes. 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 So yeah, everyone has got it. Answer would be option C only. Sigma 1 minus sigma 2 by 2. That is quite correct. Because they are both at the opposite ends of the diameter, right? So sigma 1 minus sigma 2 will give me the radius of Mohr circle. But uh, there is a cat. There's quite a catch to it. The radius of Mohr circle can also be computed using some more this tau max also. And you guys would say like how would it be possible? So if you recollect it, see we have sigma 1 as sigma x plus y minus 2 plus minus sigma x minus sigma y by 2 whole square plus tau xy whole square. Sigma 2 as sigma x plus sigma y by 2 Yeah, let's write it properly. Plus here minus sigma x minus sigma y by 2 whole square plus tau xy whole square, and tau max is equal to what? Plus minus sigma x minus sigma y by 2 whole square plus tau xy whole square. Okay. Now, since you guys already know the option C, right? So for option C, we need to use sigma 1 and sigma 2. So let's try to use it, and what will it give me? So sigma 1, uh, so sigma 1 minus sigma 2 by 2 would give me what? So these are same, so this will get cancelled out, and this will get added up, so it will give me like twice, and then I'm taking the denominator as by 2, right? So finally it will give me only this sigma x minus sigma y by 2 whole square plus tau xy whole square, and that is equal to tau max. Okay, you guys can see. So correct answer would be option A and option C both. I hope that is clear for you all. Moving on to the next question now. Mm, Question number 12. Okay, these are also a nice thing. Okay, so we have discussed this question in detail. I hope most of them can give it the answer quite quickly to this question. So we need to find the Mohr circle representing the condition of pure uniaxial tension. Okay, pure uniaxial tension. Rakesh is saying answer as option A. Is it for this question? Others? Others can also give their views. I I expect others to give answer as fast as possible to this question. Rakesh has given answer as option A. Others? Naruto Sumake. If I may, can I know the real name? Uh, who has the name as in Naruto Sumake? May I know your real name, please? Sai Kiran. Okay, yeah, thank you. So Sai Kiran has given answer as option B. I'll just hover around the previous discussion. So this was the previous discussion where we discussed in detail about the hydrostatic stress and then other kind of standard cases. You better see this than see this question asked right now. So Vignesh has also given as answer as option B. So I'll just try to wrap it as soon as possible. You guys are taking a lot of time. So I would ask you all to please go through the lectures as much as possible, because it seems you guys are not working it out. So correct answer is option B. And why would that be? Because the first case represents the case for pure shear, right? As we discussed it earlier, we have discussed it in a lengthy way. Then this is the case for pure uniaxial tension, and these two are similar. This is a general case, right? Both are similar. Okay. Now moving on to the next question. I hope Rakesh, you better check it properly. Question asked. Okay. You guys will get it. No issues. Just work it out as much as possible. So pure uniaxial tension case. I'll just uh, draw that case for you. Pure uniaxial tension case is this sigma. Okay. So you draw the Mohr circle pertaining to this case. Uniaxial tension. And for pure shear, either draw this pure shear, either draw this, or either sigma sigma, either draw this. Okay. Yeah. So B is good. Yes. Okay. Moving on to probably the last question of the discussion session. Maybe. Let's see. Okay. Let's see. So, and actually, question 13. An actually loaded bar is subjected to a normal stress of 170 megapascal. The shear stress in the bar is. An actually loaded bar is subjected to a normal stress. So if I may, sigma x is equal to 170 megapascal. That is what it is given. The shear stress in the bar is. So kind of this is a case of uniaxial tension. If you see, understand the question properly. So an axially loaded bar is subjected to a normal stress of 170 megapascal. The shear stress in the bar is. So uniaxial tension case. This is the uniaxial tension, right? This one. Okay. So if you see, uh, I'm trying to solve it through more stress. You can solve it through the calculation also. I'll try to solve it both ways. Okay. Okay. So first thing, okay, let's do it conventional way. So we are given with sigma as 170 megapascal, or if I may, I'll just write sigma x, sigma y, that is equal to 0, and tau xy is equal to 0. Okay, this case. Now, uh, so sigma 1 is sigma 1 comma 2. I'll just write sigma x plus sigma y by 2 plus minus sigma x minus sigma y by 2 whole square plus tau xy whole square, that is equal to sigma x plus sigma y, and that is 170 by 2 plus minus, this would be also 170 by 2 whole square plus 0. So finally it would be equal to what? 170 and 0. Okay. that is sigma 1 is equal to 170 megapascal, sigma 2 is equal to 0 megapascal. That is what is given already in the question. We need to find the shear stress. So this shear stress in the bar is that like if there had been an option 0, like, because it doesn't specifically says the maximum shear stress in the bar, it just says shear stress in the bar, so we could have said 0 also, right? But this not an option of 0, so probably the question says what is tau max in the bar, and that would be equal to what? Plus minus of sigma x minus sigma y by 2 whole square plus tau xy whole square, and that is equal to, this is 170 minus 0 by 2 plus 0 square, that is equal to plus minus 170 by 2, that is 85 square, and that is plus minus 85 megapascal. 85 megapascal, so tau max is 85. Okay, so as Pashupuleti also said in answer as option B, so that is correct. Okay, let's see if I can give you any more questions. Mm, okay, easy question. Question is, if I just normally we had been discussing like questions when sigma x, sigma y, tau xy is given. If I directly give you the principal stresses, would you be able to find the tau max? So the question is principal stresses at a point. So I'll just directly write, if sigma 1 is given as 80 megapascal and sigma 2 is given as minus 40 megapascal, what would be tau max? Options are 25 megapascal, option B is 35 megapascal, option C is 55 megapascal, and option D is 60 megapascal. Let me know. Okay, Pasupuleti has given answer as option D. Others, quickly so that we can wrap the session as soon as possible. Sai Kiran has also given an answer as option D. So yes, I'll just move on. Okay, so answer is option D, and why would it be? So tau max is equal to, so as we discussed earlier, like this. So tau max is equal to sigma 1 minus sigma 2 by 2, right? Tau max is equal to sigma 1 minus sigma 2 by 2, and that is equal to 80 minus 40 by 2, that is 80 plus 40 by 2, that is 120 by 2, and that is 60 megapascal. Okay. Okay, last question for today's session. Okay. Uh, Similar to this only. I'll just try just change what we want to ask. Okay. Question is, we are given with question is the radius of Mohr circle of stress of a stressed element is 20 Newton per mm square, and minor principal stress is 10 Newton per mm square. The major principal stress is, options are 30, 50, 60 and 100. All are in Newton per mm square. Tell me, uh, what would be the answer? It's quite straightforward now. I think you guys should know it at hand. We are given with the radius of the Mohr circle and minor principal stress. We need to find the major principal stress. You guys, earlier I asked you like to find the radius of the Mohr circle. How would we be able to find? Okay, so Vignesh is already come up with his answer as option A. Okay, let's try to solve it. So radius of a circle, as earlier asked you, it is given by sigma 1 minus sigma 2 by 2. We are given with the radius as 20 Newton per mm square and sigma 2 minor principal stress as 10 Newton per mm square. Okay, so just substitute it, 20 sigma 1 minus sigma 2, that is uh, and this would be 20 into 2 sigma 1 minus 10 sig, this is 40 sigma 1 minus 10, this would give me sigma 1 equal to 40 plus 10, that is 50 megapascal or 50 Newton per mm square. And nobody came up with the correct answer. Pashupulati gave answer as option D, while Akhil gave answer. Okay, Akhil was correct, and Vignesh gave as answer as option A. Okay, so at least we have some hope around here. The answer is 50 Newton per mm square. Whoever has got the wrong answer, better see what you made mistake, and we'll work it out in the future also. Mm, this is where I hope to wrap the session. Okay, let me ask last question. This would be for sure the last question of today's session. Okay, question would be question is it's just a theoretical question. So the symmetry, as earlier I told you about the symmetry of stress tensor, uh, at a point in the body that or body under equilibrium is obtained from, and for sure this would be the last question, so don't worry. uh, Question is options are conservation of mass, second is force equilibrium equations, then conservation of energy, and final option is moment equilibrium equations. So you guys can give the answers. So what would be the correct answer? So according to this question, yeah, it talks about the symmetry of the stress, right? Sigma x, sigma y, sigma z, tau xy, tau xz, tau yx, tau yz, tau zx, tau zy. So sigma transpose equal to sigma implies tau xy is equal to tau yx, tau xz equal to tau zx, and tau yz equal to tau zy. Answers? So this symmetry of stress tensor at a point in the body under equilibrium is obtained from which of these laws? Like which law suffice this symmetry of is the consequence for the symmetry of the stress tensor? Quickly, think this must have been taught to you. Anything? What do you think? What is the most appropriate? You guys can. Okay, Vignesh is saying related to conservation of mass. Vignesh is saying is option A. Others, don't worry. Whatever be the case, be wrong. Then this is not the grading scheme. You guys be correct in the actual exam. Okay, you guys look it up. The correct answer is moment equilibrium equations. Okay, so moment equilibrium equation, through that actually this itself is the these are itself like the moment equilibrium equations, one way or the other. Okay, so we'll wrap our session here. If you guys have any doubt, like any doubt in the discussion session for today or in the previous session or in the lectures, you guys can ask. I'll wait for like 1-2 minutes if you may, if you guys, otherwise then we'll wrap it up. Okay, so I think everybody is okay. Nobody has any doubt. this is the most important part of today's session, which includes standard cases, uniaxial tension, pure shear, and the hydrostatic stress. So you guys best look it up because most of the questions will be asked on this, and uh, kind of this will be provided with sigma x, sigma y, tau xy, and we need to find the maximum minimum principal stress and the maximum shear stress and the angle pertaining to it. Right, it's a standard question, so it's quite easy. It's best to remember the formula itself. Okay, so can we wrap it up? Can anybody give affirmation? We can wrap the session today here. Can we close the session? Okay, thank you all for joining. See you in the next day, same time on Saturday 4 to 6, and we'll be discussing questions relevant to assignment number 3, and by that time assignment 1 and assignment 2 a due date would be crossed, so I'll be discussing those questions also, and for that we'll keep our undue time for the discussion a bit less because we'll be discussing more questions relevant to assignment number 3. Okay, so thank you all for joining. See you next week. Thank you. Bye, take care, have a nice day. Yeah, you're welcome, everyone. Bye.